talks here. I'd like to talk a little bit today about a study we did in the Upper Schoharie Creek, 2010-11-12. It was a project funded by the Greene County Soil and Water Conservation District, probably passed through dollars from New York City DEP. I don't know if Tom Van is here. He's a representative. Before I get started, I'd like to acknowledge the support we got from them, as well as the Rochester Institute of Technology, their imaging center there, Don Kuhn, Jason Ballring, Marty Smith with New York State DEC, and in particular Scott George. I wasn't going to mention Scott, but since he did all the work, put together my presentation, and let me get it, I think I should acknowledge him as well. The main objectives of the project were to increase our knowledge of thermal conditions within the basin, more or less at the request of the Schoharie Creek Stream Management Program with a consortium of interested agencies to better manage or help better manage the Brown Trout fishery within the basin. Specific goals of this study were to document contemporary thermal conditions within the main stem of Schoharie Creek, as well as one sub-basin, to identify temporal and spatial variations in water temperatures throughout both of those systems, the availability or potential availability of thermal refuges, and to speculate a little bit about the implications these data might have for resident trout populations, the health of individuals in the system that has a naturalized population of brown trout, as well as stocked fish during each year. Our approach was relatively simple. We obtained fine-scale temporal data from 7 fixed loggers, temperature loggers. They are operated, most of them, for about 2 years. We probably got data for 12 to 18 months from all the loggers. Then we also obtained fine-scale spatial data from single remote thermal infrared flight. You get a little spatial data from our fixed loggers as well. But the thermal data from the temperature loggers were compared to optimal growth and survival thresholds for brown trout to go ahead and estimate the temporal limitations, stresses within each of those locations, as well as to ground truth some of the infrared data. We also wanted to identify spatial variations at the growth scale across the study reaches from down in the basin to the upper part of the basin. The thermal data from the infrared flights we used to detect, again, the location, the magnitude of temperature differences, the proximity of potential thermal refuges throughout the basin, as well as to characterize those relative differences throughout each of the locations, each of the hundreds of millions of actually instantaneous locations up and down that basin, how the waters within the channel, across the channel, related to each other, as well as the spatial distribution at one point in time, a snapshot of suitable and unsuitable stream temperatures during the time of that flight. This is one of our fixed loggers. They're again located in a number of different locations. Hobo trans logger installed into a galvanized pipe, put into a section of channel where we had relatively deep, foot and a half, 2 foot deep water that was moving and not sampling near the surface, not in the backwater. They actually performed fairly well, except for occasional theft and Irene, which mentioned. We actually had all these 7 transmitters out there, and they all survived Irene. This one in particular spent a year under about 3 feet of water before we finally dug it out. The ones that we actually had buried, we put out a secondary logger and monitored the thermal conditions for that period of time until they were recovered. One spent a couple months under. One was beaten to death, but we recovered most of the data. These are the locations for the fixed loggers throughout the basin. Schoharie Reservoir down here had a site above at the USGS Prattsville gauge. Schoharie 1, move up the channel to the very top of the reach near Elka Park, Schoharie 7. And we had transmitters or loggers placed just above and relatively closely below each of the major sub-basins, East Kill, West Kill, Tavia Kill. So you see a transmitter above and below here at the Tavia Kill, Bear Kill comes in there. West Kill here, we got a transmitter above and below. We had one transmitter on the West Kill. Our funding was fairly limited, so we only did one of the sub-basins, even though the main channel was our primary target. This is some of the data from fixed loggers at two locations. Schoharie Creek 1 on the top, which is up near Elka Park, or Schoharie 7 near the top, up near Elka Park. Schoharie 1 down near Prattsville. This is the uppermost logger, lowermost logger. And this is discharge data from Prattsville gauge, located down here at Schoharie 1. Between about the 1st of May of 2011, 1st of October 2012, you see the discharge information here during that period. I'd like to point out a couple different things here. In each of these two graphs here, we show this optimal growth range for brown trout between about 10 and 15 degrees centigrade. We also show the upper thermal tolerance limit, which is about the one-day average temperature above which you would get brown trout mortality, 25.3 degrees actually, for both of these two locations. And a couple other things to note here, in particular at this upper gauge, you'll see that the temperatures actually surpassed that one-day survival threshold for a couple days during 2011. During 2012, they get up close to that, but they do not surpass that threshold. Down here at the lower basin, you'll see at lower gauge that during 2011, again the summer 2011 is over here, they surpass it for 6 to 8 days. During the summer of 2012, over here, they surpassed that one-day threshold for survival, basically for 3 weeks. That shows you two things. You get real differences, thermal differences from year to year. You also have a pretty wide range of thermal conditions and stresses from the lower part of the basin to the upper part of the basin. Now, I'll connect the dots a little bit more in the next graph. Actually, this is a table summary of our fixed logger temperature data from 2011 on the left and 2012 on the right. On the left here are the site locations. Schoharie Creek 1 is the furthermost downstream site, Schoharie Creek in Prattsville. And you go upstream to Schoharie Creek 7, which is near Elka Park, and West Kill, which is one of the main tributaries that we monitor down there at the mouth. Average temperatures here show you they range from about 18 to 21 degrees during a 3-month period, June, July, and August 2011. During June, July, and August of 2012, those averages were about 1.5 to 2 degrees warmer. Interesting, the air temperatures were not any different between the 2 years. The flows were a little bit lower. We had odd read in between that actually may have cleared out a little bit of riparian habitat. More important, I think, we just look at the number of days that the water temperatures exceeded the one-day survival threshold or tolerance threshold for brown trout. In 2011, in all the locations from Schoharie Creek 1 up to 6, there's 3-4 days where the temperatures surpassed that threshold. The furthermost site up here, Schoharie Creek 7 Elka Park, did not surpass the threshold. In the West Kill, pretty much mid-basin coming into the Schoharie Creek, you did not surpass that threshold. Move over here and look at summer 2012. Basically, at all the locations, the main stem of the Schoharie Creek, there was 1 to 3 weeks almost where that threshold for survival was surpassed. That's telling you it's not good. Brown trout are not going to be happy. They're not going to grow. They're going to lose weight in many of these locations throughout that 3-month period. And a lot of them, in fact, probably most of these locations are not going to survive. They're going to be gone unless there's some place for them to get away from that to hide. To get a little bit additional spatial information, more fine-scale spatial information, basically give one day the Rochester Institute of Technology flew thermal imaging flight, fixed wing aircraft, August 7th of 2012, probably from about 10 to 12 in the morning. Flew at several thousand feet. I think this one was at 10,000 feet. This slide, I think they actually fly at 4,000 to 5,000 feet. And they collect an image every few seconds as they go up and down this channel. And it's not just one flight up and down, 10 minutes up and then they're done. It actually took about 2 hours to fly probably several hundred different tracks so they get the plane level and they fly exactly in the location that they get the channel and not miss the channel, which you'll see later on it didn't work out perfectly. But they shot 4 images at each camera shot, shortwave, IR, medium wave, infrared, and long wave infrared, as well as a visual or RGB color image. And that information was basically merged together by them initially here to give us a mosaic from the lower section of the river down near the Schoharie Reservoir all the way up to Elko Park, as well as the West Kill. They shot probably close to 700 images, 350 in that range were not overlapping that were used to stitch this together. Again, this is about 60 kilometers or 36 miles of river section. And as you can think about it, if this is 30 or 60 kilometers, there's actually a 1 meter pixel resolution. So we had every meter of this river surface image during this flight. And the data gap there is one of the things, is about a mile missing there. That navigational error, data lost. I'm not quite sure where it ended up. I think the plane actually missed the main stem by several hundred yards, and that data's gone. This is the type of imagery that we get. We actually determine the temperature off the, I think, the long wave, not incorrect there. What we needed to do before we could evaluate the temperature of the river, we had to do a couple of different things. We had to pull out the river from the background information and the land surface around it. So this imagery shows dark here, which is sort of cold. The lighter image is the warmest. And the river is somewhere in that mess of data there. And you've got to go ahead and draw the boundary basically along that river before you can analyze it. Pretty much get a shapefile of that information that you want to look at. So they had a automated electronic attempt at doing this for us, and this is what we got from that. And if you look at that, it's like, maybe that's not too bad, but it probably could be a little bit more fine-tuned. It looks like there's some things off to the side that don't really go along the river channel. And is this the river over here? Is this the river over there? So we actually throw a visual image over that to try to evaluate really where everything lies and what's in the river and what's not. And that visual image, when you plot it out there, you see a number of different issues here. We got a pond over here, a shaded roadside area, a bank or a ditch along the road. Here's some riprap that is showing up. A lot of that is water. A roof of a building nearby that shows up as water as well. So we had to pull that out. And on top of that, we also had an issue with shading and a number of orientations where the shade